Hi guys, welcome. Today is day 25. So we're looking at lessons 61 and 62 today. So if you want to flip over there, lesson 61 is when we're looking at problems where we may be adding three or more fractions. We've added fractions, subtracted, multiplied, done all that with fractions. It's just we may have some problems where we have more than two that we're adding. The same rules apply. We got to have common denominators for all of them. We need to simplify our solutions. So nothing really changes. It's just going to become a little bit more work, but all of the same rules and principles apply. So if we look at 1/2 plus 1/4 plus 1/8, okay, we want to come up with the least common denominator. That's where we've been practicing least common multiple for quite some time now. That can help us quickly come up with the least common denominator. So we want the lowest number. We don't want a big number that they all go into just to add them all together and then have to work really hard to reduce it at the very end. If we can do the least common denominator, it's going to make life a little bit easier for us. So we have 1/2 plus 1/4 plus 1/8. So again, multiples 2, 4, 6, 8, 10, 4, 8, 12, 8, 16, 24. 2, 4, 6, 8, 4, 8, and 8. Okay, so that's 8 is going to be my least common denominator. So to make 2 into 8, I got to multiply it by 4. I'll do the same thing top and bottom to keep it equivalent. We're just renaming. We're not changing the values. 4 times 2 is 8, so I multiply top and bottom by 2. So I get 4 8s plus 2 8s plus this one is already over 8, so we don't need to do anything with that one. Again, we just are going to end up with the denominator, so we don't add those together. But we add the numerators. 4 plus 2 is 6, plus 1 is 7, 7/8. Can't reduce that, so there is my solution. So it's the same thing when we worked with two fractions, but now we may have 3 or 4 or however many. We have to do the same process in order to add them all up. We need common denominators. We want to find the least common denominator so we don't have to simplify more than necessary at the very end. Again, if you're more visual and want to draw the diagrams and show what's going on, 1/4 and then half and then 1/8, well, that would give us, if we had 8 slices of this pie, 7 of them would be taken. For me, that is more work than just finding a common denominator and adding. But if this works for you and that makes sense, then go ahead and do it. If we have 1 1/2 plus 2 1/3 plus 3 1/6, even though they're mixed numbers, the same rules are going to apply. 1 1/2 plus 2 1/3. 3 1/6. So multiples 2, 4, 6, 8, 3, 6, 9, 6, 12. 6. They all go into 6. So again, this is going to be multiplied by 3 over 3. This one 2 over 2, and this is already over 6. So I get 1 3/6 plus 2 2/6 plus 3 1/6. So again, the values furthest to the right are the fractions. So I'm going to start there. 3 plus 2 is 5, plus 1 is 6. That's going to be 6, 6. And then whole numbers, 1 plus 2 is 3, plus 3 is 6. So 6 and 6 over 6, which is 6 and 1. This is equal to 1. So again, I obviously need to simplify that. That becomes 7. Because 6 over 6 is just 1. 6 and 1 is 7. So again, you may get to the end and not have to simplify or reduce it all, or you may have to, like in this example. We don't want to leave it as this. We want to simplify it to 7. Okay, practice that. We'll go over that in class. And the second thing we're looking at is writing mixed number as improper fractions. I believe we're going to watch a video on this that the Generation Genius does a pretty good job of explaining. A couple different ways we can do it. The way I do it, maybe slightly different than the way they do it, but we get to the same thing. Again, the visual, if you're, thinking of things in terms of these pictographs and seeing these circles. I have 3 and 5, 6. Well, I have 1, 2, 3, and then 5 of the 6 shaded in. If that helps you, by all means, use it. I think that can take a lot of time, and for me, actually make it more confusing. But if you like drawing it out and seeing it, then that's fine. Again, the 3 we could represent as 6, 6 plus 6, 6 plus 6, 6 plus 5, 6, and that's a way we can do it. So, and how we convert these, well, 6, 6 plus 6, 6 plus 6, 6 plus 5, 6 equals 23 over 6, and we can't reduce that. So 3 and 5, 6 is equal to 23 over 6. Now, how I would do that, and I think this way is just more efficient, and it definitely saves time in the long run. Because if the whole number is 1, 2, 3, even, yeah, it's not too difficult. But if we had 25 and 12 seventeenths or something like that, we're going to have to do 17 seventeenths plus 17 seventeenths plus 17 seventeenths 25 times, if that was the number. That's going to be very, very time consuming. So I think a quicker way to do it is this. Okay, so if we're going here, we have our whole number. What we do is we multiply that by the denominator, and then whatever that comes out to be, we add that to the numerator, and then it just remains over whatever our denominator is. So what do we mean by that? Well, 3 times 6 is 18. 18 plus 5 is 23, and it's still over 6. So I get 23 over 6. Like I said, if we have a really large whole number, like 14 and 1/2, and we want to convert that to a mixed number, okay, well, 14, we're going to call that 2 halves plus 2 halves plus 2 halves plus 2 halves 14 times, and then plus 1 extra half for this. You can do it that way. I think that's going to take up a lot of paper and be very, very, very time consuming. So what I would do, 14 and a half to an improper fraction, our whole number, times the denominator, add it to the numerator. So 4 times 2 is 28, plus 1 is 29, 29 halves. Okay, we're done. That would have been the same as 2 plus 2 plus 2 plus 2 plus 2 plus 2, 14 times plus 1, which would be 29 halves. So you're going to get the same thing. It's just when it's some of these larger numbers, it's going to be much more time consuming to do it that way. So I think doing it this way, whole number multiplied by the denominator and then add the numerator, is going to be much, much easier and definitely more efficient use of time. So again, 2 and 3/4 is an improper fraction. We do 2 times 4, which is 8, plus 3 is 11, and we get 11 over 4. So that's what they're showing here. So again, you can do it the way where you're adding, what is this, 3/4, so we do 4/4 plus 4/4 because we have 2. So 4/4 plus 4/4 is 8/4 plus 3/4 is 11/4. For some of these smaller numbers, yeah, it's probably negligible which one is faster and which one is better. But I think when you get to some of these larger numbers, and this one, you can almost do, as you get the hang of it, do it a lot quicker. Because when we're multiplying, like 1 2/3 times 2 2/5, we have to convert it. We have to convert them to improper fractions because we can't multiply 1/3 and 2/5 and 1 and 2 and call it done. We have to convert them. When we're multiplying or dividing, not adding or subtracting, but multiplying or dividing, we have to convert them to improper fractions. So 1 times 3 plus 1. 2 times 5 is 10 plus 2 is 12. So it's 12/5. And then I can reduce 3 goes into 3 once. And then 12 4 times. So 4 times 4 is 16 over 1 times 5, which is 5. Again, we can multiply and then reduce, or we can reduce before we multiply, which is the method I prefer, just because, again, I'm all about saving time and making things easier. But either way, personal preference will get you to the correct answer. All right. That is it for lesson 62. Okay, and then we'll be doing lesson 63 next. But that's all we have. We'll do the practice set together. Bring those homework questions to class and we'll go over them. See you guys soon.